All right, everybody, we are now getting into learning target 5-2, which is about empirical and molecular formulas. All right, you guys, now before we dive into empirical versus molecular formulas, let's go ahead and look at these hydrocarbons here. Go ahead in your notes and write down something that's different and something that's the same about all of them. All right, something that is going to be different. I think we can all agree that the mass of these different compounds would be different because they have different makeups, they have different compositions. But when we're looking at the ratios and the percent composition, we can see that there are twice as many hydrogens as there are carbons. So those are some things that would be the same. When we are talking about an empirical formula, we are talking about the smallest mole ratio of elements in a compound. So 1 to 2 versus a molecular formula, which would be like a 2 to 4 ratio. So the molecular formula is just some bigger multiple of the empirical formula. So when we are solving empirical formula problems, we will be given something that looks like this. An organic sample was found to be 40% carbon, 6.63% hydrogen, and 53.33% oxygen. What is the empirical formula? Our steps to solving this: first, we have to find the moles of each element. How many moles of each thing do we have? And then we have to change that percent to grams. How many grams of each thing do we have? Then we will divide all of the moles by the smallest value. Divide all the moles by the smallest value. We'll multiply to make them whole numbers if they're needed, because we won't have any decimals in our formulas. We won't have 0.2 of a molecule, we'll have an entire molecule. And these are the subscripts for the empirical formula. So let's take these steps we just learned and go backwards and try and solve that problem that we were given. So for this problem where we have 40% carbon, about 6% hydrogen, and about 50% oxygen, let's figure out what our empirical formula is. So first, we have to convert our percents to grams, and we're just going to assume that there's 100 grams. So we're going to have 40 grams, and then we're just going to convert to grams from our percents. And we take each of those numbers and we divide it by our molecular mass. So molecular mass of carbon is going to be 12.01. For hydrogen it's this, oxygen it's this, and we get our molar values, how many moles of each thing we have in our formula. Then we have to look at our molar values and say, okay, which one do I have the least of? I have the least moles of both carbon and oxygen because I had 3.33 moles of both of those. So I'm going to take my values, all of my molar values, and divide it by my smallest value, which in this case was 3.33. And then that is how I'm going to get those numbers to make my formula. Because I've got 1 carbon, 2 hydrogens, and 1 oxygen. So what if we told you that the molar mass is actually 60.06 grams per mole? So if we calculate the mass of this formula here, sorry I don't have my pen, that's why my handwriting's ugly, we actually get about 30 grams for our molar mass. So if we told you that the molar mass is actually 60, we can figure out that 30 goes into 60 2 times, so that we need to double our amount, double our mass, and double our amount of things we have. So we can change our formula to become a molecular formula and no longer the empirical formula. Like I mentioned earlier, the molecular formula is also a multiple of the molar mass of the empirical formula. So here is my example. I have C2H4O2, and if you divide those all in half, we get CH2O. And you can see that my molecular formula here is double what my empirical formula is. So knowing this pattern, we can just continue to increase this ratio. So if the molar mass we were told was actually 120 grams per mole, then that means we would have to, again, divide our new molar mass by our empirical formula's molar mass, which is 30, and we would get 4 times. So that means we would have to multiply the amount of our atoms in our formula by 4. All right, now I'm going to give you a second and try this one on your own. So these are going to be my answers here. You can see that first I calculated how many moles of hydrogen I have and how many moles of oxygen I have. Then I took my smallest amount of moles, which is 5.87, and I divided that into both of my moles. Then I realized that my empirical formula is going to be OH, which is just the ratio determined from my percentages, because I got 1 and 1 over here. Go ahead, take a second, and try and solve this one. So to do this, I had to figure out what my molar mass of my compound was, and my molar mass of my empirical formula compound was about 17. So if my new molar mass is going to be 34, then I would have to take 34, divide that by 17, I would get 2, and then I would have to double my empirical formula, and I would get 2 hydrogens and 2 oxygens. All right, that is it, you guys. We're going to get lots of practice with this in class. Nice job following along, and I will see you soon.